In this video, I'm going to be describing how we can use the distance formula to find the distance between 2 points. Hopefully we already know how to find a horizontal or a vertical distance or length. But this may be the first time that you find a diagonal length. And in order to do that, we're actually going to use a right triangle and the Pythagorean theorem to do it. So the distance formula is really the Pythagorean theorem. It's just the same formula, but using coordinate symbols or notation instead of A, B, and C. So let's see how we can change the Pythagorean theorem into the distance formula. So if I want to find the distance between these 2 points, these are my 2 coordinates. My first coordinate pair would be x1, y1. My second coordinate pair would be x2, y2. If we actually just draw a right triangle and make that length the hypotenuse of the right triangle, then we can use the Pythagorean theorem. And you could draw a right triangle facing this way, or it could be upside down facing the other way. That doesn't matter. To find the horizontal length, we're going to use our x values, and we're going to subtract our x values to find the length. If you subtract the first one from the second one, so if you do x2 minus x1, then you should always get a positive answer. But there will be a trick coming up in a second just to make sure. So if you forget to do that, if you flip it and you subtract x1 from x2, it doesn't matter. We'll see why in a second. So the horizontal length x2 minus x1 just becomes our a value. So instead of a, we use our distance to find our horizontal length. And if you had flipped those two and you get a negative value, well, this square is going to take care of that negative value. So it doesn't matter if you had flipped the order here and subtracted, because once we square a negative number, it's going to become positive anyways. So it doesn't matter what order you subtract your x values. To find the vertical length, or maybe to replace our b, we're going to subtract our y values. And so again, if you do y2 minus y1, you should always get a positive value. But if you flip those and do y1 minus y2, it's not going to matter because we're going to end up squaring it anyways. So the b just became the distance, the vertical distance, y2 minus y1. Our c, or hypotenuse, we're just going to call d for distance. And that's really the only change there. So instead of c squared, we have d squared. So now we've replaced all of our a, b's, and c's, and we have a good start for our distance formula. The last step, to actually solve for d, or to find the distance between those 2 points, we would square root both sides. And so we get our distance formula right here. But it's actually just the Pythagorean theorem solved for c. So hopefully that clears up any misconceptions about why this is so complicated here. So let's do some examples. We're going to start with one on the coordinate plane, and then we're going to take away the coordinate plane on our next example. So we're going to find the distance between these 2 points. You could draw a right triangle to visualize it, either that way or upside down. So we want to find our horizontal length. So I'm going to subtract my x coordinates. My x coordinate here is 5. My x coordinate here is 1. So 5 minus 1 is 4. And then we could actually verify, since we have a coordinate plane or a grid to count on, 1, 2, 3, 4 lengths across. So 4 is going to replace our a in our equation. I'm going to use the Pythagorean theorem just to show you how much the distance formula is exactly the same thing. Let's find our vertical length right here. So vertical lengths are going to be a y value. So my y value here is 5. My y value here is 2. So 5 minus 2 is 3. And we could count 1, 2, 3 to verify. So to replace b, I'm going to put a 3. So now if I square 4, I get 16. If I square 3, I get 9. If I add those together, I get 25. And if I square root it, I get 5. And maybe you already knew that if I have lengths in a right triangle that measure 3 and 4, the hypotenuse is always 5. That's a special right triangle. Let's do the exact same thing, but let's just focus on the coordinates and not so much about counting our spaces on the grid. So we got our coordinates. 1, 2, and 5, 5. I'm going to label them. My first coordinate pair is going to be x1, y1, and my second coordinate pair is going to be x2, y2. I'm going to subtract my x coordinates. So 5 minus 1 is 4, and 4 squared is 16. I'm going to subtract my y values. So 5 minus 2, which is 3, and 3 squared is 9. If I add those together, I get 25, and the square root of 25 is 5. So hopefully you can see that the distance formula is the Pythagorean theorem, just with coordinates. And one last time, if we had swapped these and subtracted in the opposite order, it's okay. If I had done 1 minus 5, I would have got -4, and -4 is still positive 16. So we still would start to get the same exact answers at this step. If I had switched these 2 minus 5 and got -3 here, -3 squared would be positive 9, and so we'd be good at this step. So it doesn't matter what order you subtract your coordinates, as long as you subtract the x coordinates together and the y coordinates together. One more example. This time we're not going to look at a coordinate plane or a grid at all. So this is why the distance formula is used rather than the Pythagorean theorem. But you could always sketch out a picture of this, put it on a grid so that you can visualize it, draw your right triangle, and treat it just the same. But eventually, you want to get good enough at just plugging coordinates into the distance formula and doing that instead of drawing right triangles. So we have our two coordinates, -3, 4, and 4, 6. I'm going to call F my first coordinate pair and point G my second coordinate pair. And we're going to find the distance between these 2 points. We're going to find FG. And then we're going to practice rounding our answer. So if I subtract my two x coordinates, I could do 4 minus -3, which turns into addition and becomes 7. And if I square that, I get 49. Or if I had done -3 minus 4 and got -7 and squared that, I would still get positive 49 at this step. Let's find the difference in our y values to find that vertical length. So 6 minus 4 is 2, and 2 squared is 4. Or if we had done 4 minus 6 and got -2 here and squared it, we still would have got positive 4 at this step. So now add these squares together, 49 and 4 give us 53. And to find the distance, we're going to square root that number. And your calculator will give you the decimal equivalent of this radical number. It's about 7.28, and it goes on from there. That's all we need to round to the nearest 10th spot. The 10th spot is that first decimal place. So look to the right. If that number is 5 or more, round this number up. If this number is 4 or less, keep that 10th spot the same. So because we're 5 or more here, we're going to round that 10th spot up to 7.3. And so our distance is approximately 7.3 or 7 3/10.